Hello everyone, welcome to the next lecture on the probability and statistics. Today we will discuss about what is the method of movements and how you can solve this problem. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute, India. So what we have discussed so far is we have discussed about the maximum likelihood estimator, which is available on my channel, Dr. Harish Garg, and this method is used for finding the this method is used to estimate the parameters which are unknown in the probability distribution functions. As we have seen in this lecture while solving the problem, that the method is quite obvious, but mathematically it is a very tedious to solve the problem. Why? Because you have to firstly look about this likelihood functions like of this, and then you have to take the logarithms, and then you have to take the partial derivative. So it will take the tedious process. Then our target is to find a new method. We will discuss a new method which will be help to estimate the unknown parameters, and that method is called as the method of movement. So we will learn a different techniques for estimating the parameters called as the method of movements as MOM. Before understanding the method of the movements, we must understand what is the meaning of the movements. So there are the two kinds of the movement. One is called as the population and second is a sample. What is the difference between them is, once you are talking about the population, consider a population X whose distribution depends on the unknown parameter. What is the meaning of that? So if I say if X is my population which follows the normal distributions, how many unknown parameters in this normal distribution? One is the mu, second is sigma square. So these are my called as theta 1 and this is my theta 2. Similarly, if you consider say X is my binomial distribution, how many unknown parameters in the binomial distribution is? One is a n, second is a p. So this is my theta 1 and this is my theta 2. So the number of the unknown parameters involving in the distribution is called as theta I star. Then we will define the rth moments called as the population moments are there, denoted by mu of this. So clearly says that when I consider mu of 1, that is r is 1, it is nothing but my expected mean. If you consider 2, r is 2, then it is of e of x square and then so on. Once you defining here, this is. Another thing is, once we define the moments about the point C, so we consider here. Clearly says that when you consider C as my 0, then all these moments becomes my here. So remember, the population moments are denoted by mu of r. On the other hand, what is the sample moments are there? If you consider any of the IID samples, as then the rth sample moment is denoted like of here. That is, if you consider m1, it is nothing but my, what is that? This is xi upon n. What is the m2? That is nothing but xi square divided by 2. What is the m3? Is nothing but my summation of xi cube divided by n and so on. That's the only difference between here. This is a population mean, this is a sample. And similarly, if you define about the C, it is nothing but my x minus C. Clearly says that what will happen if r is 1. So clearly says that what will happen, this is nothing but my xi upon n. Do you remember what is that? This is nothing but my sample mean. Another thing is, whatever the sample moments are there, that doesn't depend upon the population parameters, while these unknown parameters are depending upon the population moments. That's why we always working on the sample moments, try to locate the population unknown moments. And our target is to find the estimators of this theta. So as clearly as I discussed that, what is the value of the m1 is nothing but my sample mean. Now, what is the method of the movements? So if I consider x is my any of the random variable with respect to some distribution called as here, and this unknown parameters is my here, then this method of the movements estimates these unknown parameters. How you can do that? You can equate the population movements to be the sample movements. So you can equate these two, population and the sample movements, as equality, and then try to find the values of theta from here. Like of this, you can see these are my population movements, these are my mu. What is the mu of r? This is nothing but my here. So when r is 1, it comes to be here. When r is 2, it comes to be here, and then so on. So after solving this, you will get the values of the unknown parameters. And this method of movements is denoted by theta cap. Is represent for the method of movements. How you can solve them? I will discuss about the two-step rule. That's a very simple approach are there. The first step is you will try to compute the population movements. These are my population movements. You have to try to find the how you can do that. That's depending upon the distribution, whether it's a discrete or continuous here. What is the second step is you have to equate this population movements with the sample movements. Once you will equate them, and then you have to find these unknown parameters from here. What is the consistency of these parameters? Whether the method of movements is consistent estimator or not, that's a very simple. Again, if you know these are my xi's, which are the random samples of here, what is the meaning of this random sample? It means they are my IID. Once each of the xi is my IID, then what is the meaning of this here? These are also IID, that's a clear cut are there. So which theorem is applicable when you consider about the IID? That is nothing but my weak law of the large number. Once the weak law of the large number is applicable, that means if expected value of all these exist, then by using this weak law of the large number, this converges in probability. That's the meaning of the convergence in. So what is that? What is the meaning of this? This is nothing but by MR. It converges to this my here. So that is the sample movements are converges to the population movements in the terms of probability. So what is the meaning of that? Once this will happen, what is that? This is the consistent estimator of this. That is the sample movements are my consistent estimator of the population movements. Now once it's a consistent estimator, it means you can use the sample movements in place of population. But what are the remarks about that? Whatever the estimators you have obtained from the method of movements, that are always asymptotically normal, but they are not efficient. Also, if you are trying to solve this any of the problem with the help of the method of movements as well as the MLE, then the method of movements are less efficient than of this. We will see in this video example number 3 are here. What is the meaning of that? If you have some distributions, you solve this problem with the help of the method of movements, you solve this problem with the help of the MLE, then whatever the answer you obtain from here is a less efficient than of this MLE. Since it is a less efficient, it can be equal, so it can be identical when the method of movements can be identical to the MLE, when the PDF is represented in the form of exponential of this power series. So let's see, we will discuss about the 8 to 9 examples in this video so that you can easily understand this concept. Now I will tell you the two-step approach are there, how you can solve any of the problems in this simple method. Look about the function are there. First, your target is you have to think about this function. How many unknown parameters are there? Look at that, how many unknown parameters in this case. So since x is not the unknown parameters, the only unknown parameter is my theta, that is only 1. So once it is only 1, then you have to need only ex. If there are the 2 unknown parameters, then we need to find the ex and ex square. If there are the 3 unknown parameters, then we will try to find the ex square and ex cube and then solve. But in this case, there is only one unknown parameters, that is my theta, so we will find the ex only. Since it is a continuous parameters, continuous distribution, we will find here. We can substitute this e of x at here, you will get this value. How you solve this integration? That's very simple. You can take x square is my y. What is the value of the x? X is nothing but my root y. So d of x is my 1 by here. Now you can substitute all these value here, you will get this answer. Now you can see I can take this power as a common, which can be written here. You can see this is nothing but my gamma integration. This is nothing but here. So here n is my half. You can substitute here, you will get this. Again you can see what is that? This is nothing but theta raised to power half. What is the gamma function of 3 by 2? It is nothing but half gamma function of half. What is the gamma function of half? Is root of pi. So you can see here. This is my step 1. Now by using the method of movement, what is the meaning of that? This is r is 1, this is m1. What is the m1? As I discussed, this is nothing but my here. What is that? This is nothing x bar here. Now you can substitute the e of x. What is that? E of x is nothing but my here. This is nothing x bar. Can you find the value of theta from here? You can get is the required estimators by using the method of movements. Look at the next example. How many unknown parameters are there? Again you can see how many unknown parameters. There is only one are there. So it means our target is to find the ex. I can substitute this value here. you can get this. You can see 3 theta cube is constant. This is my here. So what is the integration of this? When you take infinity, this is 0, when is here. Now what is the method of the moment says? This is the one unknown, so we can see here, that is that this is nothing but m1. So I can take x bar is, what is that? This is 3 upon, can you find the value of theta from here? Yes, you can do easily. That is the required answer of this problem. Does it always make sense? Clearly says that it makes sense only when x bar is my non-zero. So does it always make sense? No. When it makes sense? Yes, it makes sense if x bar is my non-zero. Again, you can see how many unknown parameters are there. You can see this is my only one. So you can find the value of here. You can substitute this value, you will get here. What is the 1 by x is? Log of x. But when you take log of infinity, that doesn't make any sense. It means we are unable to find the value of theta from this pair. So therefore, we will try to compute the e of x square. Now again, you can take the integration. What is that? This is x from here. Again, when you take infinity minus something, that is, again, it doesn't make any of the sense. Again, we will try to find the e of x cube. What will happen? This is my x cube. When you take x cube, it will be my theta of x. Again, once you take the integration from here, this will be my, again, it doesn't make any of the sense. So what is the meaning of that? It means this method of the moment is not applicable to this kind of this problem. However, if you try to solve this with the help of the maximum likelihood estimator, then you can easily find the value of theta from here. So that means the method of the moments is less efficient than of the ML. Look at the another one are there. How many unknown parameters? You can firstly identify that. How many unknowns? There are only one unknown. It means your target is to find the EX firstly. But here you can see this problem is my discrete. So once it's a discrete, then you have to write in this tabular form. How you can write the expected value? This is x into px, that is this into this into this, you will get here. Now by the method of the moments, what will happen? By the method of the moment, this expected value, that is m1, is nothing but my e of x. m1 is nothing x bar, and here. Can you find the value of theta from here? You can easily do. This is here. Can you find the theta from here is, that is a 2 minus of here, or you can say 2 is common, 1 by this. So that is the required estimator of this method of moments. Look at the another one here. Now this kind is very important. Such kind of the questions are usually asked in the CSR net or GATE examinations or other competition examinations are there, or somebody called as the IIT jams are also be there. And the concept is very simple. You have to see the estimates by the method of moments. Forget about these numbers. Firstly, you have to think about here how many unknown parameters are there. Again, you can see the unknown parameters is my 1, only theta. It means your target is to find the value of EX firstly. So we can do like this. This is my constant taken outside. Can you integrate this? You can solve like here. Now, by the method of the moments, what you can do that this E of X is nothing but my m1. m1 is nothing but my x bar. So it means you can like here. Can you find the value of the theta from here? You can easily do. You can see 2x bar plus theta of x bar is nothing but my here. So you can take the pair of the x bar and theta separately. You can get the values as here. This is the required estimator of this. But now it is given to you. The sample is my here. It means can you now we need this value. So for this we can compute the value of the x bar, sum divided by 5. You can easily do here. Substitute this value in here. You will get the estimator of theta is my. This is a simple procedure. Look about here. Now again, how many unknown parameters are there? Only one. It means we need to find this one. But here you can see this is the PDF formula for this. In the last example, last 5 examples, it is f of x is given to you, but in this case it is not given to you. You know what is that? This is nothing but my uniform distributions. So once it's a uniform distribution, we all know that if x follows the uniform distribution, then the PDF is my here. So corresponding to this, can you find the PDF of this? 1 upon theta. So once it is here, can you find the expected value? X into fx of dx, range from 0 to infinity. So once you will solve, you will get the answer. Otherwise, we also know that the expected values of the uniform distribution is a plus b upon 2. In this case, a is my 0, b is my theta. So can you find the value of the expected value? A plus theta upon 2. Now since there is only one unknown parameters, so by the method of the moments we can equate here. This is nothing but x bar. So can you find the value of theta from here? You will get this as a required answer. There is no need of the variance in this case. But you can see in this example, how many unknown parameters are there? So there are the two unknown parameters, alpha and beta. It means we need to find the value of the ex, and then we will find the value of ex. What is that? It is a gamma distributions. Once you know that it's a gamma distribution, we already know that what is the mean of the gamma distribution. That is my here, variance is my this. From this variance, we use this formula, we can compute here. This is the first method. Otherwise, what you can do that, we will find the value of the ex by using here f of x dx, this is my fx, and e of x square is x square into fx of dx. And after solving, you will get the same answer of this and answer this. Or you can, let me show you, I can start the e of xr. So we can substitute the value of the fx here, and again we will use the gamma function. You will get this here. So when you take r is 1, what will happen? This is e of x, left hand side is here, gamma function of the alpha plus 1, beta raised to power 1, gamma function of alpha. What is the gamma function of alpha plus 1? Alpha of here. So what is that? It will be cancelled out, that is alpha upon beta. Similarly, when you take this, it will be alpha plus 2 is a beta square, gamma function of alpha. What is the gamma function of alpha plus 2? That is alpha plus 2, alpha plus 1, gamma function of alpha. And here you can see alpha is cancelled out, so it's alpha plus 1, alpha plus 2 upon here. Now what is the method of the moment suggest? It means this suggests to you is equal to the m1, and this suggests to you as a m2. So that is, you can substitute this value. E of x is alpha upon beta is my m1, and alpha plus 1 alpha upon beta square is my m2. Now on solving these two equations, you will find the value of alpha and beta. How you solve them? You can see it's a beta square, we can find the value of the beta here and substitute in this case, or otherwise we can scale them and then divide. So once you will scale them and then divide it, you will get the value of alpha here. We can substitute this value of alpha here, you can find the value of beta. So these are the estimators for this unknown parameters. Again, they are talking about the sample size. So what is the meaning of that? You have to find the values of the m1 and m2. These are the formula for the m1. Sum divided by 3 is 126. How you compute that? That's a 120 square, 130 square, 128 square divided by 3 you will get here. Substitute this m1 and m2 in this alpha 1 and alpha 2, you will get this required answers. Look at one more example. Again, it is given to you the uniform distributions. How many unknown parameters are there? There is only one unknown parameters. So we will try to find the ex only. Again, you can use this, you will get answer as. So by the method of the moments, what will happen? m1 is 0. So what is the meaning of that? It doesn't contain any of the unknown parameters. So it means this is no use for us. Once it is a no use for us, then we will try to find the e of x square. How you find the e of x square? We can use this variance formula. What is the variance of x? B minus a. What is that? This is nothing but my b. This is my a. So what is the b minus a is over 12. So what is the answer of this? This is nothing but my 3. So variance is my theta square upon 3. We can find the value of the ex square here. this plus 0, that is nothing but my here. So therefore, by the method of the moments, what you can do, this E of x square is nothing but my m2. So we can substitute this value as of, we can find the value of theta from here is the required answer. If you are unable to find the value of theta from here, then you have to find the value of ex cube, but here we easily find. Look at the last example are here. Again, this is the continuous distribution. How many unknown parameters are there? The unknown parameters is only 1, that is the beta. So it means we have to find the value of ex from here. So let's start with the value of the ex. We can get this. You can see the value of beta is common, it's outside. So what is that? This is nothing but my x raised to power minus beta. Now you all know that how you integrate them. This is nothing but my minus beta plus 1 minus beta plus 1 over 1 to infinity. Once you substitute infinity, the answer will be 0. Once you substitute 1, it will be my here. Why? You can see once is a 0 minus 1 upon here. So I can adjust this minus with here, you can get. Now since we in this expected there is unknown parameter, so by the method of the moments, what you can do, you can take, what is the method of the moment? You have to take this value as of m1. This is nothing but x bar. So beta upon this is nothing but my x bar. Can you find the value of the beta from here? You can easily do like of this. And what is that? This is beta is common, x bar minus 1 is my x bar. So what is the beta from here? X bar divided by x bar minus 1 is the required estimators of this beta is. So this is the way you can solve these problems in a very simple way. If you want to find some another videos related to this testing of hypotheses as well as the parameters, you can see this Kramer-Raumler and then so on, all are available in the testing of hypotheses playlist. Channel name is my Dr. Harish. I hope you can enjoy this session too. You can like, share and comment this video and share with your friends. Till then, best of luck students. Happy learning.